So this is section 5.3b. This is the second part of imaginary numbers. And what we talked about in the last video was that if you have a negative under the radical, under the square root, that's an imaginary number. And then to simplify, you just put the symbol I, the letter I, on the outside to represent an imaginary number. So if you look at these examples that we already did for 1, 2, and 3, it's okay to have an I as a part of your answer. On number 5, when we did the math, it turned out we didn't have any I's, and that's okay too. But look at number 6, I to the 82nd, all right? That's not okay. So I means something if it's just a single I. All that means is it's an imaginary number. But having a higher exponent on your I squared, I cubed, I to the 5th, or like on number 6, I to the 82nd, there's no such thing as being more imaginary. So since it's just I or not, then we need to think about how are we going to replace an I to the 82nd, or an I squared, or an I cubed, so that we don't have a higher exponent for I. So look up here at the top. So we said that I to the first, that's just the same as I, and the definition is that it's the square root of -1. Okay, so think about if you had an I squared. So if you had an I squared, I'll do the math over here. It's kind of like saying, hey, you have a square root of -1 times a square root of -1, right? Because that would be like an I times I. But if you multiply a square root by itself, doesn't that just cancel the square root? So wouldn't that just equal -1? So what that means is anytime you see an I squared, we're just going to change it to be -1. Not negative I, just -1. Okay, well, what about I cubed? Well, I cubed is the same as I squared times I. And we just said that I squared is the same as -1. And if I multiply that by I, wouldn't that just be negative I? All right, which is okay. Remember, we said it's okay to have an I in your answer, but it's not okay to have an I squared or an I cubed or something else. All right, so what about I to the 4th? Well, that's the same as I squared times I squared. And since each of those I squareds represents -1, that's like saying -1 times -1. Well, -1 times -1 is +1. So far, every one of these I terms that had a higher exponent, we were able to simplify it down to being either no I's at all or just a single I. Well, what about, can we do that with I to the 5th? Well, if I have I to the 5th, that's the same as saying I to the 4th times I. And remember, I to the 4th is just 1. So 1 times I is just I. And you'll notice what's going to happen. I could keep going all day long, but basically what's going to happen is you're going to end up with this pattern starting to repeat itself. Let me go up here a little bit. There we go. This pattern is starting to repeat itself. So where the pattern starts with I and then -1, so here's your I. So this would be -1. So I to the 7th would be the next number in the pattern, which would be -I, and so on. So every 4, it's going to repeat itself. So if you think about number 6, if I have I to the 82, well, it's going to repeat itself every 4. So you're going to have the first 4, and then the next ones take you through I to the 8th, and then the next round takes you through I to the 12th. And if you think about it, if the exponent is 82, to get to 80, it's going to be one full round all the way through the I to the 1st, all the way down to I to the 4th. That's going to get you to the I to the 80, but then you have 81 and 82. So basically, if you come up here, here's my 1 through 4, my 5 through 8, my 9 through 12, and I keep going, and I'm going to end up with through I to the 80th. So here's going to be 81 and 82. So this is just going to equal -1. So really, it's just all about this number being divisible by 4, and then what are you going to have for the leftovers? Let's do another one like that just to see if you're tracking with me. So let's come down here to number 11 real quick. So when I first multiply this, just use your basic exponent rules. 5 times 8 is 40. I squared times I to the 5th is going to be I to the 7th. Okay, but we said you can't have an answer that has an I to the 7th in it. You can have an I, but you can't have an I to the 7th. So if I go all the way through I to the 4th, remember the pattern starts, it's like I, -1, negative I, and then +1. So this is going to take me through I to the 4th, and then this would be 5, 6, 7. So I to the 7th is the same as -I. So you have 40 times -I, which is actually -40I. Okay, so anytime you have an I term that has more than 2, you need to figure out how to replace it. Now, that's going to happen on occasion, and you might see it on a standardized test, but the more likely would be a problem like number 9 here. So on number 9, if I simplify, if I just distribute, I'm going to have -4I, which is fine. And then if I distribute 2I times 3I, it's going to be a +6I squared. Well, remember we said we don't want to leave any I squared terms. So leave the -4I, replace the I squared with -1, because that's where we had what we had in the pattern. And so you actually have -4I minus 6. So it's okay to have an I, you just can't have an I squared. Or look down here at number 12. If I do the FOIL, the first, the outer, the inner, and then for the last, my 4I squared. So I've got 7. If I combine those two middle terms, that's going to be 16I. But then we can't have an I squared, so that 4, replace the I squared with -1. So isn't this really just a -4? And now you can combine that with that 7, and so you're going to have 3 plus 16I. Okay? Let's see, did I cover it? Now, if I come up here to number 7, the reason I had skipped over them is because there was going to be no problem. Now, this is not a FOIL. If I have a minus right here, I do need to distribute that negative. So I've got 2 minus 5I. If I distribute, that's going to become a +3. Distribute again, so that's going to become a +8I. Now I do want to combine like terms. So 5, when I combine the 2 and the 3, -5I, +8I is going to be +3I. But it's perfectly fine to have that as your answer, because you don't have an I squared or an I cubed or anything as a higher exponent. You just have an I. And the same thing is going to happen with a problem like number 8. So what does that mean for problems down here like 13 through 16? Well, okay, back up. If I want to solve for x, you might try solve by factoring, you might try using quadratic formula, but it doesn't matter which one, you're definitely going to have to set it equal to 0. So 2x squared. In this case, notice there's no x term, right? And if there's no x term, then maybe I don't need to try and factor. Maybe I'll just subtract that 11 on the other side. So that's going to become a -48. And if I divide by 2, and then last step, take the square root of both sides. So x equals, all right, so now it's all about, hey, let's just simplify the square root of -24. So because of the negative, we put an I. Remember how we talked about simplifying square roots? Just start breaking that down. Well, I know that the square root of 4 is 2, and since I can't take the square root of 6 evenly, I'll just leave it on the inside. So there's my solution. Let's go one more on number 14. Again, there's no x term in the middle, so I don't need to worry about factoring. I'll just subtract that 33. So 5x squared equals -30. Divide by 5. So in order to solve, I'm going to take the square root of both sides. So x equals, now over here you have an I, but you can't break down the square root of 6, right? I mean, even if you say 2 times 3, nothing's going to come to the outside. So just leave, just leave that square root of 6 on the inside, and your solution can look like that. Okay, 15 and 16 are very much the same thing. I don't think we need to do both. I'll go ahead and do one more. Let's look at number 16. So again, there's no x term. If that 7 had been an x term, yes, I would set it equal to 0 and either do the quadratic formula or try to factor it. But in this case, there's not an x term, so I don't really need to go that method to solve. I'll add 7. So 3x squared equals, let's see, if I add 7, I'm going to get negative 24. Is that right? 24 and 7, yeah, 31. Okay, so if I divide by 3, x squared equals negative 8. Okay, so in order to solve, I'm going to take the square root of both sides. So x equals, so I'm definitely going to put the I out there because of the negative, but the 8 can be simplified. If I think of 8 as 4 times 2, right, I know that the square root of 4 is 2. So for the 4, I'm going to get a 2 on the outside. But that 2 is just extra left over, right? I can't take the square root of 2, so it's going to have to stay on the inside. So there is going to be my simplified answer. Okay, so that's the last of the imaginary number practice.